I kind of feel like we've come full circle a little bit. What this slide says is, remember I said if we're starting a little tally there, and we have covalent or molecular compounds over here. Remember that means the same thing, molecular and covalent compounds. We have ionic compounds over here. Remember I said that if you see a metal, then it must be an ionic compound in the formula. If you see no metals, likely it is a molecular compound. And actually this tries to kind of show you how that goes, because also I said if it's an ionic compound, then you have at least one ionic bond. And you have an ionic bond because goodness, I hope you can read that. At least one ionic bond. If you have an ionic bond, because the metal actually gives up an electron, just like we saw with the sodium given up to the chlorine. And over here, molecular compounds, electrons are all shared here. Okay, so I hope that's all kind of working for you. And we'll be talking more about, especially ionic compounds, when an electron is transferred, what that looks like. We'll be diving more into actually both of these. What else? Well, on this slide, you see at the top the delta chi, the electronegativity difference. Electronegativity difference. Anytime you see that triangle, that means difference in. Now remember, what does the bars mean? The bars mean the absolute value of. So all this is saying is if you have A joined to B and you wanted to come up with electronegativity difference, you could look up the chi value for A, the chi or electronegativity value for B, and we could do a little subtraction, electronegativity difference, okay? Take the absolute value of the difference of those two, okay? Right. Well, here's the deal. We said that actually if it gets up to 1.7 or greater, okay, then electron's going to be transferred and you're going to end up with an ionic chemical bond, right? But anything here actually is going to be, electrons are going to be shared, right? Does that work? Right. Now I want to bring back water right quick, if that's okay with you. I think we came up with electronegativity difference between the oxygen and the hydrogen is 1.2, which actually is kind of strong. So I'm going to go ahead and put my oxygen, hydrogen, hydrogen, okay? Now, which one is more electronegative, the oxygen or the hydrogen? Well, the oxygen was more electronegative, so actually that carries what we call partially negative. That's a lowercase delta. I know it looks like an S, but it's S with a funky thing right there. So partially negative, and that means this is partially positive and partially positive. These electrons here, that actually two electrons that are being shared to create those, each of those chemical bonds, they aren't shared equally. So if we kind of see a cool map of where the electrons are, the electron cloud is a little bit more this way than that way. So that makes it partially negative. Anytime you see this kind of separation in charge like this, it's not an ion, okay, but it's a separation in charge. It brings a degree of what we call polarity. As it turns out, water is pretty strongly polar. Something that has electronegativity difference of 1, the electrons will be shared but not equally. That's called polar, weakly polar, nonpolar. See how that works? Yeah. Those are all, though, covalent types of covalent. Electrons are shared, covalent chemical bonds there. So this is just kind of try to show you from left to right. Clear over here on the left, you can kind of see how the electrons are being shared equally. This is like the electron cloud, okay, between A and B. Okay, here we have A and B, and you can see that actually A has more electrons. It's partially negative, okay. B is partially positive. Here, an electron must have been transferred from the metal to the nonmetal. So the metal becomes positively charged and the nonmetal is negatively charged. So these are some examples. If you were to look up, we said this electronegativity difference was what, 2.1? Electron was transferred from the sodium to the chlorine. Here, electron is being shared but not equally. And here in this, remember we said that chlorine, it was one of those diatomic elements. So in the chlorine molecule, that's what I want to say, actually it looks like electrons are being shared equally, which totally makes sense. Electronegativity difference of 0. So again, I think I've kind of said this as much. Hopefully you've started your tally, and we're going to be, I think, adding to it maybe just a little bit more. But if you have a formula, and I'll tell you already, your Unit 3 exam, excuse me, I'm going to give you some chemical formulas, and you have to tell me whether it's an ionic or a covalent compound. And all I want to tell you is if you look for the metal, it's an ionic compound, okay? And you might kind of remember, is salt ionic? Yep, salt's ionic. So sodium chloride is ionic, and sodium is a metal. So if there are no metals, it's a covalent compound. And I leave you with, dun dun dun, homework that's due.